Welcome to A-Level and AP Physics. In today's lesson, we will discuss important past paper questions from March 2021 paper 1-2. These questions are very important for your exam because you will see the same kind of questions in many past papers. We will discuss these questions in detail so you can have better understanding of these concepts. For question number 14, it is given to us a balance is used to measure the mass m of a number of cylindrical metal rods of length L. All the metal rods, they have the same radius R. The graph is given here. You can see on y-axis m is given, on x-axis L is given. The gradient of the graph in this case is equal to capital G, and for this question we need to find out which expression gives the density of the metal. First of all, let's try to visualize, means try to see the picture of this question. For that purpose, we need to sketch this cylindrical metal rod. So this is our cylindrical metal rod as it is given in this question. The radius of this rod is given, that is equal to small r. So this is the radius of the rod. Now let's say the length of this rod is equal to L1. Let me sketch another rod so then we can compare these two rods. Let's say this is our second rod, and this second rod also have the same radius. This rod also has the same radius and its radius is equal to small r. Let's say the length of this second rod, this is equal to L2. This is. Now if I ask you, these two rods, they are made of the same material, they have the same shape, only difference is that one is longer and the other one is shorter. Let's say the mass of this shorter rod, this is M1, and the mass of the longer rod, this is M2. You will simply say that in this case M2 has to be greater than M1 because L2 is greater than L1. This is what is given in the graph. You can see as the L is increasing, it is increasing this way, and the mass is also increasing. Means mass and L, they are directly proportional because the rods, they have the same shape, they have the same radius. So it means same material, they are made of the same material. So let me write down here. As they are made of the same material, so it simply means that they have the same density, same material. It means the density is the same, radius is the same, radius is same. So what does it mean if the radius is same radius also means that the cross-sectional area of each rod, this is also the same. Now we have to use these concepts to answer this problem. Let's try to find out how we can find the mass of each rod. If we need to find the mass of rod, simply we can say that that has to be equal to the density of the rod, means the density of the material, times the volume of the rod. So V is the volume. In this case, the shape of the each rod is cylinder, so the volume of cylinder simply is equal to A times L. A is the cross-sectional area. We can also write down the cross-sectional area. This is pi r squared times L. In this equation, density is constant, radius is constant, so we can place them on one side. So this is rho pi r square. We can draw two brackets across them, and this is L. If you look at this equation now, this is straight line equation. We need to compare this one with y is equal to mx plus c. C is the y-intercept, but in this case the line is passing through origin. It simply means c is equal to 0. X quantity is L because this is plotted on x-axis, and the gradient here we can write down m is the gradient, and m is equal to rho pi r squared. So this is the gradient. For this question, it is given to us the gradient of the graph is equal to capital G. It simply means that we have to replace m with capital G. So this is a gradient, and the value of gradient here, that is equal to capital G. So this is pi r squared. We need to find out density, expression for the density of the metal. So rho is the density. Simply we need to rearrange, then we can write down rho is equal to capital G divided by pi r squared, and this is expression for density. That's the answer. So this is our final answer. For question number 15, it is given to us there are two blocks X and Y. This is block X and this is block Y. They are on a horizontal frictionless surface, so this surface is frictionless. The mass of block Y is greater than the mass of block X. Block Y has a spring attached to its end. You can see this is the spring is attached at the end of block Y. The blocks are pushed together, the spring is compressed between them, and the blocks are stationary. When released, blocks move in opposite directions. We need to find out which statement is correct. For option A, it is given to us after release, the kinetic energy of block X must equal the kinetic energy of block Y. Simply we can write down according to this statement, kinetic energy of block X is equal to kinetic energy of block Y. If we look at our system, we can simply understand it is given to us the blocks are pushed together, means we apply force F, let's say on this block, and we apply some force F on this block, and we push them together, and the spring between these two blocks is compressed. Now if we remove these forces, we remove these two forces, block Y will go to the right. Let's say the velocity of this block is Vy, and the block X, this will go to the left. Let's say the velocity of block X is Vx. This is an example of explosion, means system will split into pieces, into smaller parts. So this is an example of explosion. For an isolated system, its system is isolated, means there is no net external force acting on the system, then momentum before explosion has to be equal to momentum after. So we can write down momentum before has to be equal to momentum after. It simply means that momentum before is equal to 0. It simply means that the momentum of X must be equal to momentum of Y. So this is momentum of Y. So Px minus Py, it has to be equal to 0. So this is the first thing we need to understand. If we take this side, for example, this momentum is positive and this has certain momentum, let's say Px, and the momentum of this one will be negative because this is in the opposite direction. So it simply means Px minus Py, this will be equal to 0, or simply we can say the Px, this has to be equal to Py. If we look at kinetic energy, so kinetic energy is equal to P squared divided by 2m. If momentum is the same but the mass is smaller, kinetic energy will be greater. In this question, it is given to us the mass of block Y is greater and the mass of block X is smaller. So we can write down here as mx is smaller than my. It simply means kinetic energy of X will be greater than kinetic energy of Y. So the kinetic energies are not equal, so this is not correct option. As you can see, I have written here momentum is conserved, kinetic energy is not. They have different kinetic energies. Their kinetic energies are different. It simply means kinetic energy of X is not equal to kinetic energy of Y. Let's move on to option B. For option B, it is given after release the sum of kinetic energies of the block is 0. So that is not true because after release blocks are moving with certain velocities. As we said, the velocity of block X is Vx, velocity of block Y, this is Vy. The kinetic energy is not 0 because kinetic energy is a scalar. So this is also not true option. If we go to option C now, it's telling us the total energy of the spring and blocks before release is 0. Before release is not 0 because the work done by the forces we are applying to push them together, that is stored in the system in the form of elastic potential energy. So the total energy before release is not equal to 0. So this statement is also not true. Spring and block system has elastic potential energy. So this statement is also not true. If you look at statement D, means option D, total energy of the spring and blocks is equal to the energy needed to bring the blocks together. It simply means the work done by you or work done by the applied force, that is equal to elastic potential energy, means the energy stored in this system. And this is based on law of conservation of energy. Energy is conserved. So this option is true. For question number 16, we need to find out the work done by gas in moving the piston. How we can find out the work done by gas? Let's say this is W, this is the work done by gas, or this is the work done on gas. That is equal to P external. So this is P external times delta V, and this formula we only use if the P is constant. P has to be constant. So this is very important point you need to understand. When you can use this one only if the P is constant, means P external is constant. Now if you read this question, it is given to us the cylinder has cross-sectional area and the diameter of that one is given, that is equal to 20 centimeters. Pressure of the gas is 102 when the piston is initially 30 centimeters from the base of the cylinder. So this distance is given, this is 30 centimeters. The gas is heated, causing the piston to move up to, that is 35 centimeters. The pressure of the gas remains constant. Pressure of the gas remains constant. We can also understand like this. At this point, gas is exerting certain pressure. Let's say this is P gas, and there is external pressure on the gas, that is P external. These two are equal. That when we heat up, the pressure will increase, the gas will expand, and finally at this point again the pressure of the gas and the external pressure, these two are equal again. So at this point, P gas again equal to P external. Value of P external, then simply we can find out from here. This is given, this is 102 because P external is the same. So we can write down this is 102. Now we need to find out the change in volume of the gas. Let's say the change in this height, let's say this is equal to delta H. We need to find out the change in volume, so that simply is equal to the cross-sectional area, we can say pi by 4 d squared times height. So this is the change in height, means delta H. Now just we need to plug in values and we can find out the work done by gas in moving the piston. So this is pi by 4 and d squared, this is in centimeters, so we have to multiply with 10 to negative 2, and the change in height is also in centimeters. 35 minus 30, so this is 5 multiplied with 10 to negative 2. Now if we solve this one, our final answer will be 0.16 joules. So this is the work done by gas in moving the piston. So this is work done by gas. In this case, work done by gas is positive. So this is work done by gas. Option A is correct, and this is the best possible answer for this question. Let me explain to you one more point. P of gas, it is only constant at initial position and at final, but it is not constant between initial and final.